Okay, how many milliliters of this molarity? So I'm trying to find one of my volumes. I'm going to call it volume 1. That's my molarity one. Is required to prepare. Okay, so see milliliters. So that's volume 2 and molarity 2. Again, I've got that F word in there. And then double check my units. So milliliters and milliliters. Okay, I'm good. I'm going to come out with the right unit. That'll be good. So at this point, pause and solve these problems, and then log back on, or pause and then restart it so you can watch me work these 3 problems. So we got 0.224 molar, or molarity, times volume equals 5.0 times 10 to the 2 milliliters times 0.055 molarity. Then I divide both sides by the 0.224. That's going to give me volume is equal to 5.0 times 10 to the 2 times 0.55, sorry, 0.055, and 0.224 molarity. Notice that this was a molarity and that was a milliliter, so those cancel. And notice that will give me the correct unit, which is milliliters. You plug that in your calculator, you're going to get that number. The reason it's 2 sig figs is because I have 1, 2 right there. Or you could say I have 1, 2 right there. Either ways, 1, 2 sig figs. And hopefully you remember how I said how to write that with scientific notation if you needed to. Next one, what's the molarity of solution formed by adding, okay, volume 1 of A, see of, so those are tied together, molarity 1, 2, and then here's our volume 2. And then we're filling it to the mark with distilled water. If you watch that little video, you could see what that meant. So basically you put one solution in, and there's a marking here, and you add enough water, and then you mix it all up. That's how you get your new dilution. So MV, so 2.50 molarity times 30.0 milliliters equals 0.1000 liters times molarity. Now, I just noticed something, and you might have noticed this too. I didn't do my little check. So let's double check my units here. Oh no, my units are off. So I either fix it in the problem or I fix it outside the problem. You may be able to do this in your head, and if you can, that's awesome. If you can't, it's the liters times in 1 times 10 to the minus 3rd liters in 1 milliliter. That's going to give you 100 milliliters. Actually, 100.0 milliliters. So I need to change this number and make it 100.0 milliliters. Now I should be good. Divide both sides by the 100.0. 2.5 molarity times my 30.0 milliliters divided by 100.0 milliliters. Those canceled. When you put that in your calculator, you're going to get this number over here. I dropped a 0, and that's why at first it looked like I didn't have the right sig figs. And last one. So if we have 50 milliliters of a 6.50, so again, volume 1, molarity 1, of is that, sorry, molarity 2, molarity 1, that of is that tying word together, is diluted to give, so this is our second molarity. What is the final volume? In liters. So quick check. Are these the same? They're not the same. So at the end, I need to remember to convert. I'm going to come out in milliliters. So I'm going to remember to convert my milliliters to liters. Or at the beginning, I can go ahead and convert my milliliters to liters. Can you do it in your head yet? You do it the same way as up here. You should get 0.050, 1, 2, yep, liters. That's my volume, oops, times my 6.50 molarity equals my volume 2 times my 1.30 molarity. Divide both sides by 1.30, 1.30, again molarity, molarity. Those numbers cancel, and when you plug it into the calculator, you're going to get this number over here. Notice that it's to 3 sig figs. You can pick out any of these. All of these all had 3 sig figs. All right, so in review, we talked about a solute. So that is, again, you can pause if you want to answer these really quick on your own. A solute is a substance that dissolves in a solvent, which describes a saturated solution. One that can hold as much solute as it can at a given temperature. True and false. Solute is added to a solvent to make a solution. That is true. Solvent is the least amount of substance in a mixture. That's false. It's the solute that's the least amount. That's the smaller word. Without changing the temperature or pressure, you can make a saturated solution more concentrated. No, that's false. You need to make a saturated solution is as concentrated as you can get at that temperature and pressure. Supersaturated would be when you're changing the temperature or the pressure. Okay, molarity is one of many units of concentration. That's true. There's others. To determine the molarity of a solution, you divide mass by volume. That should be moles. And this is going to have to be in liters, so that'd be false. It doesn't matter if you use the solvent's volume versus the solution's volume in determining. That is false. You have to use the solution volume. Volumetric glassware, now if you watch those videos, you would have seen this one, has been designed to change concentration easily. That's true. Again, if you want to see that one, go watch that video. That's most closest to this section. And when you're diluting a solution, you have to convert all the volume units to liter. That is not true. No, but they do have to be the same. So they both have to be either be liters or they both have to be milliliters or I don't know, centimeters cubed, whatever you're using, they just have to be the same. And dilution changes the mole amount of solvent in a solution. That is what increases, yes. This does increase, because this is just saying it changes the amount of water in a solution. So yeah, that's what you're doing. So that's true. We have our learning indicators. Hope this wasn't too long for you. I just want to make sure and spell out every